All right, so to go along with all of these limits and things like that, what we've looked at so far is what happens when a graph approaches a specific y value from both sides. In other words, if we were to just real quickly before we dive into this example say the limit. Whoops, here we go. The limit as x approaches to of 3x. What we're really saying is what's going on when x is 2, and the answer to that is the y value is approaching 6. And we can see from both sides of the line, and if we look at this, if we just graph this line, we're going to have some line. It's going to look like about like this. And when we look at 2, right here, 2, we're going to have a y value of 6. Well, that happens on both sides of this y value, okay? So it doesn't matter what side I'm coming from, I get to that y value. But one of the things that can happen is you can have a y value approach a specific y value from the left and then another y value from the right. And so that's what this example talks about. And that's what this rule is for one and two-sided limits. So a function has a limit as it approaches a specific number if and only if the right and left-hand limits exist and are equal. So back to this question that we drew up here really quick. When I come in from the left and I come in from the right, I approach the exact same number, okay? And for your notational purposes, this guy right here is from the right, and this guy right here is from the left, okay? So when you look at these examples that we've got down here, that I've put down here for you guys to check out, notice that on my step function, I've got these straight lines, and as I come into, say, 1.5 from the left or the right, I've got one number from the left, I've got another number from the right that I'm approaching. And so we would talk for this particular guy right here, we would talk about a left and a right hand limit. Okay? Sometimes piecewise functions are equally crazy. So if we call this like say 1, 2, 3, 4, 6, 7, 8. Okay? As we come into 1, there's nothing from the left. Like there's nothing from the left that we approach. But as we come in from the right, on the 1, we're approaching this guy right here. Let's just call him 1. Okay? So this would only have a right-handed limit. And in fact, if you look at all of these, the only on this piecewise function, the only one that isn't just a single-handed limit, coming in from just right or just left. The only one that isn't is this point right here. We've got a limit because we're approaching the same thing from the left. Let me get that little mark out of there. Approaching the same thing from the left as we are from the right. Now my marker won't work. What the heck? Here we go. So as we come in from this way, from the left, and we come in from the right, we hit one spot. Okay? But on all these other guys, this is only going to have a right-handed limit, only a left-handed limit, only a left-handed limit, only a right-handed limit, only a left-handed limit, and only a right-handed limit. And so none of these actually have a specific limit except that guy. Okay, so it's kind of a lot to take in, but check it out. If you have questions you need to ask, you can always tweet to at HazelCalc or Hazelwood Math, or you can hashtag HazelCalc, and we'll see those questions and answer those as best we can.